Machine Hazards by Nathan Glennon. So we're going to start off with some basic definitions so we're all on the same page when I end up diving in further depth later. So we're going to start off with what is considered machinery. Machinery by the CSA standard is an assembly of linked parts or components that at least one of which moves, so it has to have at least one moving part, with appropriate machine actuators, electrical circuits, and control. So these all have to be joined together for a specific application, in particular for processing, treatment, moving, or packaging of material. Our second and final definition is a machine hazard. A machine hazard, by definition, is a hazardous situation created by the result of either powered or manual tools, equipment, or machinery. So it doesn't necessarily have to be something plugged in. Nowadays, it's more likely and more apt to be a energized tool, but even manual tools such as our knives that we're creating for our class project can present a machine hazard. So types of machine hazards. Here I have 8 listed. I'm sure there's plenty more that if I wanted to dive further in depth I could find. But right here we have moving parts. So any moving part on a machinery, piece of machinery is likely and can cause damage or injury to somebody or something. Number 2, we have energy. We've all dealt with this with lockout, tagout before. So we know to control and de-energize a machine before it's worked on or when we are done working with it. 3, we have heat or cold. I'll dive further in depth with this later about forging and welding and stuff like that. 4, we have noise. So any loud tools such as jackhammers or impacts, anything like that. 5, we have vibration, which can also be part of like the jackhammer pneumatic tool kind of area. Number 6 is something that's not common to us and we most likely won't see in an industrial setting, is radiation. It is very helpful in the industrial setting, but it's not commonly used. Number 7 is fluids under pressure. As we know, gas and liquids are both considered fluids. Most of us have dealt with these when it comes to hydraulics and pneumatic courses. And finally, 8, we have psychological hazards in the workplace. Moving part hazards, number 1. There's a wide area of moving parts that can cause severe injuries. There's a lot of injuries in that category itself. For example, entanglement. When we're working on a piece of machinery or working on a lab, we all know that we keep our sleeves either rolled up or we don't have long sleeves on. We know people tie up their hair or tuck in any exposed like laces or anything like that. Next we have friction, so any kind of like sanding or anything that's a fast moving part. If you were to touch that, it can potentially burn or scrape your hand to a severe degree. In almost the same category we have abrasions, and then next we have a somewhat of a semi-category of cutting, severing, shearing, and puncturing. So anything that has a blade that's meant to cut at a certain time or anything like that, no matter what it's designed to cut, can potentially hurt and cut you or people around you. Then for the final subcategory, we have impact, crushing, and trapping. As we all watched in the Dave Davis video, I believe that was his name, where the young boy was on his first day on the job, never received proper training, and within his first couple hours he was crushed and killed to death. We all have gone through courses to train us to avoid situations like that, and that's why, because they are relevant and still happening in factories. So next we have energy hazards. Every machinery is going to use energy of some sort nowadays, for the most part. And whenever there's energy, there's a source of hazardous situations. For example, whether a machine is getting maintenance and it's not unplugged and properly locked out and tagged out, somebody can get shocked on it. Or when a machinery is plugged in, you risk hazard of being crushed or being cut or any of the moving parts. Hazardous areas are applicable to this. So next is heat hazards. Heat can either be a requirement for a process to build something, or it can be a product of us building something, or both. So examples of hazards when it comes to heat are degrees of burns. We've all at one point touched something that's hot, whether it be a stove or a wood stove or something of sort, and it hurt enough for us to realize that we don't want to do it again. So the rest of the things in that category are heat exhaustion and heat stroke. So when we think of that, we kind of think of, working outside too long in the summer or something of that nature. But in an industrial setting, it's more or less being trapped in a suit to protect you from sparks or forging of something of the sorts. And inside of that suit, it can get very hot. And for a long period of time, if you're in that, it can bring substantial hazard to you. So examples of these situations where these are possible are forging areas, welding areas, brazing areas, which is kind of in hand with welding, or any metal bending that's using heat instead of just blunt force. And next we have cold machine hazards. So extreme cold conditions are not commonly seen in an industrial setting. When we think of cold up here, especially, we think of like snow removal or something like that, but that's not an industrial setting. Hazards that deal with cold weather are more or less like hypothermia, frostbite, or trench foot. In an industrial setting, the most likely application that you're going to see severe cold is using liquid nitrogen. It's used in the transportation of chemicals. It's used as a coolant for vacuums and superconductors. And when it's used for those things, you risk having it being able to splash in your eyes as any fluid would, and that will completely dry out your eyes and cause severe tissue damage to any skin that it comes in contact with. Also with this, when it's used as a superconductor coolant and a vacuum pump coolant, what can happen is you risk high pressure situations where it could possibly explode. And finally, you have asphyxiation. When you're dealing with liquid nitrogen, when it's exposed to the air, it swells and its volume will expand up to 695 times when it vaporizes. Next we have vibrational hazards. So as we've seen in industrial maintenance labs, when something's misaligned or bearing goes bad, it has more of, instead of a perfect circular flow to it, it has an elliptical pattern, which can cause constant vibrations. And with this, people have witnessed and concluded that there can be lower back pain issues, motion sickness, bone damage, varicose veins, and heart conditions from constant change in blood flow and circulation. Some people have experienced stomach and digestive conditions, respiratory and endocrine and metabolic changes. So that's a very wide category and hard to narrow down to exactly what it is affecting in your body. But and then lastly, a common one is impairment of vision, balance, or both, which could be something like vertigo, for example, is something that you could experience because of it. Vibration hazards part 2. We have what is called hand-arm vibration, or HAV. Long-term exposure from using hand tools that are like pneumatic tools or concrete breakers or grinders or even chainsaws cause a range of conditions and diseases that range from white finger, also known as dead finger. So what will happen is you'll experience whiteness in your hands and there'll be no blood flow to it, and there'll be pain in your fingers. Something that a lot of older people that have been in the workforce for a long time can attest to is carpal tunnel syndrome, and it's very similar to occupational overuse. So if you work too hard for too long, you'll experience certain symptoms that can eventually cause constant pain and trouble in moving your wrists. Next, you can experience sensory nerve damage. So a lot of what you're experiencing in your hands will feel you'll have like a lack of sensitivity. And finally, you have muscle and joint damage in the hands and arms. So something you can relate this to would be like tennis elbow. And next, what I was talking about earlier is radiation hazards. So radiation can be used for a plethora of things in an industrial setting. It's not something when you think of radiation, you don't boom think industry and like plants and stuff like that. But what does come to mind as a common factor is X-rays. So a lot of times for quality control, you'll see X-rays being used on more complex parts to make sure the inner machinations are all correct, instead of tearing the thing apart and trying to see how it functions and putting more wear and tear on the machine. It's also used to enhance material quality. I won't dive into the actual process of it for lack of time, but it's used in hardening high performance polymers, whether it's for racing plastics or for more like constructional needs. The health risks for these processes aren't extremely high, but with long-term exposure, you can accumulate severity over time with like developing cancers and things like that and illnesses from radiation. Gas or liquids under pressure. So I touched on this earlier about hydraulics and stuff that most of us have done. As I'm sure some of us have seen, there are certain hazards that can come from this. For example, burnings from hot fluids and high pressure sprays, bruises and cuts. So say you have a hydraulic line that's not completely fitted on and you turn it on. As soon as that system's under high pressure, you risk having that hydraulic line flail off and whip around and hurt you or somebody else. And they have a very heavy metal end on the end, so it can really do some damage. And then finally, if a line were to be cut or have a small hole in it, you have hydraulic fluid splashing out onto people. And that's potentially hazardous because it can be very hot at times. Psychological hazards. So this isn't something that's very, very common or seen as like a big issue. It's very overlooked, I would say. A lot of times there's people stressing out in jobs where maybe they're new and they're worried about their performance and they're constantly worried about what they're doing instead of focusing on the job. And a lot of times people can be overworked from taking too many hours or too much overtime. Next, we have lack of work organization. So say I'm very neat and I like to keep my work area clean, and Devin here next to me doesn't like to keep his area clean. Well, for me, that could be a big issue. That can potentially risk somebody falling, slipping, or if there's an emergency, that can cause a lot of injury. And next, we have cognitive factors. So with this, a lack of an attention span, for lack of better terms, it's really what it is, to put it bluntly. Memory disabilities or learning performance disabilities. So if somebody's not picking up on things, eventually they probably would be eliminated if the problem's not fixed. But it can cause severe injury to those around them and themselves during the process before they get fired. So now I have tips on working safely around machinery. So this is kind of a list of things you could do to prevent being hurt in an industrial setting and prevent hurting others, because above all, as much as you have to worry about other people doing things, you have to worry about your own actions, not hurting just yourself, but proceed with caution on things to prevent other people from being hurt. So, understanding how a machine is designed that you're working on and how it works. You want to fully understand the machinations of it and understand what it's going to do and when it's going to perform said task. If it's something that's set to cut on a timer, or if it's something that brings a large impact down to compress something, you want to be able to identify all hazards associated with it. If they're not blocked off to where you can't get your hands or arms or body parts stuck in something, you want to be able to identify where you can put your hands and where you can't put your hands to reduce injury. And with this, you want to always use proper PPE, as we're always taught. Whether it's by our professors or other professors in the building, we're always drilled with wearing our safety glasses and proper clothing. And eliminate hazards when possible. If you see a hazard, clear the hazard or talk to your supervisor about the hazard. And preventing machine hazards part 2. Through using proper and adequate PPE, or personal protective equipment, most hazards can be either prevented or minimalized to enough to reduce injury and save a life. And practicing the proper use of using PPE is crucial when working or even passing through a manufacturing facility. For example, in the IAM building, we don't exactly produce a lot of things, but we have labs being worked on, and we have tours coming through and other students and professors, and we want to make sure that we're safe as well as the people that are passing through, because we want them to see what a good facility we are. And you don't want anybody getting hurt no matter how far they are. We make sure that the welding booths are closed and everybody has safety glasses on and stuff like that. And part 3 of preventing machine hazards. Another vital step is ensuring the safety of all the employees is training. Training is also often overlooked, and people are they really dread it when they start a new job, but it can be potentially life-saving to you and those around you. Say they could cover new material that maybe you haven't experienced yet in a job setting, and that can shine some light on things that you didn't think about to protect you and to protect others. And as many of us have seen, what's common sense to us isn't always common sense to other people. We might have a lot of knowledge in a field that this could be their first day, like the young man in the video that got crushed. He didn't know that there was potential hazard to be crushed on there. He just went and did it because he was told to. And one last way to prevent machine hazards in the workplace is commonly having inspections by supervisors. Supervisors should readily have SOPs available for each station and have them custom set to that station. SOPs should discuss what the regular operating procedure is, what kind of PPE the person needs, and how to use the PPE, when it's needed, and should also be discussed whether or not you can add modifications depending on the setting. And lockout, tagout. A lot of people can be hurt because of not properly locking and tagging a machine out, whether it's by being shocked like I mentioned earlier, or having moving parts be a hazard. A proper lockout, tagout procedure should be included in all SOPs. And the following guidelines of lockout, tagout are also something that seemed as very, very dreadful and monotonous and redundant, but it's something that is very, 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 very good, because it protects you and protects a lot of people. And once a machine is locked out and tagged out, it's very obvious not to turn on the machine, and you can't because it has a lock on it if possible. Alright, now I have a little multiple choice question quiz for you guys. And don't sweat, I'm not going to grade you too hard, you know. Which of these are not a common hazard of moving parts? A, crushing, B, impalement, C, radiation, or D, lacerations? The answer to this question is choice C. This is because radiation was not a hazard of moving parts, as I mentioned before, but radiation is a hazardous subcategory on its own. Number 2, constant vibration while working can affect your body. True or false? The answer to this question is true. As seen in my presentation, constant exposure to vibration can be very harmful to your body on multiple aspects. Number 3, radiation is frequently used in the average industrial work setting. True or false? And the key here is frequently used in the average area. The answer to this is false. Although radiation is used in certain industries, it's not a very common practice that we'd see, so that's why the answer is false. Moving parts, fluids under pressure, and blank are all examples of machine hazards that were discussed in this presentation. The key here is machine hazards. A, ladder hazards, B, vibrational hazards, or C, slipping hazards. The answer to this question is choice B, vibrational hazards. The other two, which were slipping and ladder hazards, were not something that I discussed in this presentation because neither of them are machine hazards. And number 5, following the proper lockout tagout procedure will not help protect yourself and others from machine hazards. True or false? If you don't get this, Dwayne's going to be very mad. Answer to this question is false. Lockout tagout is a very effective method of protection if practiced thoroughly. So with lockout tagout, you want to make sure that each step is visited frequently and with proper practice and making sure that you're following each step. You can't do it haphazardly. And these are, wrong side. And these are my citations. Thank you.